Instead of compiling to an executable, what happens if we first compile to share libraries? I've got my a.c and b.c as before, and now I have c.c, which is going to refer to a and b. We could imagine that shared libraries are very much like executables. When we make a.so, then we take a.o, and in an executable we would have to give the code a particular address. And the same would be true of b.so. Now you see a problem that was similar to what we had imagined might happen with object files. We have to predict addresses for both A and B, but we need these to be distinct addresses. And the same thing happens with C.so. We've given it the same address also. So the code for C is overlapping with A and B, and of course it still doesn't know at this point what A and B are going to be because we haven't put these shared libraries together. You might imagine then that it's all handled the same way as linking object files in an executable, but that's not going to be quite the way it works here because shared libraries have different constraints. Right? In particular, we want the text section to be reusable without modifying the text section when we run. Right? When the linker takes .o files and creates an executable, then it rewrites the text sections as it merges them together. For shared objects, we not only don't want to have to change the file or make a separate executable file, but actually we want to copy these text sections into memory and use them as is, as read-only text. And the reason for that is so it can be shared not only on disk, but in memory among different programs that are using the shared library. So we have a problem with overlapping addresses here, and we have a problem with patching c.so's text segment to refer to the right addresses. What we've looked at so far when we were looking at .o files was position-dependent code. Right? And it turns out to make a .so file, as we saw before, you have to add the -f pick file, and that causes a program like this to be treated more like a program like we have on the right here. Instead of referring directly to a variable v, code will be generated to refer to a file-specific variable vp, this is an example of a computing problem being solved by adding a level of n direction. This reference to a file local thing can be computed as relative to f. Meanwhile, when the code is instantiated, the particular pointer vp can be filled in. Right? And that's in the writable section instead of the text section, writable data section. Same thing for AP and BP. We could do it that way by having some pointers as data and having the dynamic linker write the right addresses in. So that means that the code here, the code that's in F here, doesn't have to change at all to get the right V, A, and P. What has to change that these variables have to be updated. Right? So it's the job of the dynamic linker to know that these variables need to be filled in and to match them up with A and P, A and B and V in some other library.